Welcome, ladies and gentlemen, to another webinar in Dryden Aqua water treatment. My name is Dominic. I'm the CEO of the group, and today we are talking about filters, really about the hardware. So today very deep in filtration and what you have to look in what details and how you can check if your filter does what we promised.
We really want to be able to show what to look out for in your filter vessel, the hardware, the software being the media within the filter vessel.
We have the hardware now. We will group the filters into three. The first will be horizontal filters. We call it the pore option. Due to the geometry, we will have dead areas everywhere in the corners. We have these filters has a belly.
Like me.
So we have the areas in the ends and on the sides of the filter. Then we can have, in these horizontal filters, we are limited by the diameter for the media, that height that we can use.
Yep.
Then we can go for vertical filters with laterals. We have two options: the pore option with a shallow bed depth,
yep, very short filters, and higher depth, which are better. But we always can have the option of nozzle plate, where we have normally a better distribution, but we will see the details afterwards.
Yeah, equal distribution, and also what is to mention, if you want to backwash with air, an air purge, you need a nozzle plate. Never ever use a lateral configuration. But yeah, I mean, horizontals, they're great because they have big surface, but on the design, they are very, very challenging.
Yeah, and we'll get into more detail of that later on.
Yeah.
So one of the components we spoke about in the beginning was the top diffusers. We must check that the components that we install in the filters, they work. So we have checked and tested different diffusers in the top.
Sorry, what does work mean to you? So
what do you want?
What do you want? What do we need?
Good point, yes. We need that the surface is flat. I mean, we need that the water...
Flat filter bed.
The surface of the media.
The surface of the media is flat, so we don't have a hole, we don't have a crater, and this means that the media will go evenly through all the filter media. If we don't have this, just the example that if we can have on top of the media anthracite or sand, for example, if we have a hole, we will not have this active carbon in the middle. So the water will go directly to the sand or the AFM, which is not a very good idea and is not what we want.
Okay, but what you're saying, responsible for a flat filter bed is really the top diffuser.
Yeah.
And you checked other diffusers, like the Koenig, they are great for backwashing, but they give this turbulence where you get these mountains, other ones which give this hole. The ones that you're using, they are guaranteed that you have a super flat filter bed, and you, ladies and gentlemen, you can check it if you have a sight glass.
Yep. Every filter should have a sight glass where you can see what's happening to your bed, to the surface of your bed.
As a manufacturer, we also fight for every millimeter that we have in the filter. We need to put the top diffuser in an adequate height so that we maximize the media height that we can have inside. Or we have more space for percolation before the water gets into the media.
So what you're doing is what we see here on the right. Why are people doing the one in the left?
That's because, it's easy not to think and to install. But these are very easy to install.
Easy to install, and the other is not easy to install.
Not that.
Good. I do not mention that I forced them to put it on the right. Okay, let's go to the next one.
And this comes very much from me. It's a little bit of my bugbear, where unfortunately I see a lot of these very short filters being used in the aquarium and aquaculture, zoo industry, with the multi-port valves on the top. The reason why they're a bit of my bugbear is really they are very dependent on where the laterals can be put into these filters. Also, the laterals are generally quite short, which ends up with a very poor distribution of backwash and resulting in dead areas around the sides of these filters. But not only that, with having such a short filter, you've always got to make space for bed expansion. Like we said earlier on, you need 20% bed expansion. So in often cases, that means that you can only get a maximum of 350 mils, and I do have many filters out there that's less than that of filtration media, which would be the grade 1. So our recommendation, and these are exactly the same diameter filters, so your surface area is the same, but to facilitate very good filtration, both surface filtration and deep bed filtration, where we're really utilizing the sedimentation phases throughout this deep bed filter, you really should go for a higher filter. So it's a deep bed filter and deep lateral position as far as down as possible, and like Yasura says, that allows for maximizing the filtration media.
Filtration is coming from filtration media. Huh?
Yep.
If you're going to have 50 kilograms in or 200 kilograms in, that makes a difference, right?
We always love the 200 kilograms.
Yeah, absolutely. That's also from a commercial. All three of us, by the way, are fathers. We have to feed the family.
Yeah.
So, no, but I mean, also out there, in these zoos, I think your animals, your fish and your animals, they deserve good filtration. And therefore, you have to invest a little bit in your
and it's
hardware.
not only the good filtration, it's that all these dead areas facilitate areas where parasites and viruses can breed, right? So you really want to avoid all the dead areas in your filters as much as possible.
The left one is not a good choice.
Not a good choice.
Very bad
Not
choice.
a good choice.
Very expensive choice in the long run.
In the long run, very expensive. And the multi-port valves are not sized correctly, so their pressure losses are often very high, and you cannot achieve the backwash that you require for these filters.
Mm-hmm. Okay. Laterals. I heard that the laterals is a big story.
Yes, it's. Yes.
For equal backwashing, right?
Yes, we want an equal backwashing in all the surface. This option of a star in the bottom is very popular, and we say that they work okay up for diameters up to 950. Above that, they simply don't work. We have a big dead area in the corners of the laterals.
The pizza slices?
Yes.
Yeah.
The more the better. But we will always have some
What do you mean
space.
the bigger the slice, the better, or?
No, the more slides that we have, the better. The dead area will be smaller.
So more laterals to reduce these pizza slice sizes.
Also, if we have a big diameter and we keep with this design of a star configuration, we will have very long laterals, and we will see later that they are not also
They don't work
the best
at all.
option.
Okay, great.
Okay, this is a video which I got from a customer from Veldana, and they bought at that time these red filters. They are not manufactured anymore, therefore we can name them. And you see a beautiful red filter, and they asked
Really
them to
good looking filters, yeah.
Really good looking filters, good. And they asked them to make them a big side glass in so they can show the AFM. And can you play the video?
Yep, sure.
Here you see the video in a backwash. Now they are backwashing this filter. This filter has a diameter of 640 millimeters, so it is. And now look where you have movements of the media. Here, in 30 or 40 centimeters, not more than this. So they sent me this video and said, Dominic, what's wrong here with the media? I said, well, I guess there is nothing wrong with the media. I came to you, and you said, yeah, Dominic, this is clear. This is because of the lateral configuration. They haven't done it the right. And I asked you, can you do it the right way? And you said, we are always doing it.
Yes.
Right?
Yes.
Give me the other video. So he took a normal cold blast filter, with the normal configuration. The only thing you put in big side glasses.
Yes, we put a big side glass, and we can see here that the backwash is even in all the surface.
No, it's completely even. It's not just even. It's completely even.
Yeah. We have a proper expansion.
Look at this.
That's beautiful. Right.
It's the same diameter, 640.
Yeah.
The 640.
The same everything. Yeah.
And this is just because of the lateral configuration. Now, ladies and gentlemen, if you would have asked me, is that possible that you have, because of the lateral configuration, not even distribution? I would say yes, if you have filtered 2 meters, 3 meters, but not in 600. So I really was shocked. That was an eye-opener for me to see that you can have these problems, these huge differences in small filters.
So what does that tell you is very important?
It's super important, and you will give us now not all the secrets, but some of the secrets, how to do it right, or what's the problem.
But of course, you would never have seen that unless you had a sight glass.
Yeah,
so it's vitally important to have sight glasses in your filters.
Yeah, if you want, you need a sight glass.
Yeah.
By the way, in Cold Glass, all our filters have sight glasses.
Yeah.
You can't get it without
and
sight glasses.
as well?
In Torah as well,
Glass
yes. Yeah, that's
the marketing spiel. Yeah.
No, it's kind of our DNA. We want to be the best, and we know how important it is. And yes, it brings the price up by, I don't know, 500 euros. But I don't care. If you don't have this money, you're not our customer.
Yeah, because you've got to have the good hardware and the good software together.
And you have to control it, how you want to operate it, how you want to check it.
Yeah.
But let's go back to what we have seen. What is the difference of this red to the blue?
Yes, okay. We see in this picture that we are on the left, we see that the laterals, they are very short. They are too short for this diameter, so we are not covering the surface. So the water is just coming up through the middle. We have this filter of 600, and we have the same configuration that we do in CalPlus with long laterals that we reach to the corner, to the walls of the filter. In bigger diameters, we are not very friend of this configuration with a star, because we have a big.
So bigger, that means bigger than 1 meter.
Let's say 950, 1 meter.
Yeah.
Above that, the area are too much. So we need to go a more complex configuration. In fact, the bigger the diameter, the more complex configuration that we will have.
Yeah, and we'll see that detail a little bit later.
That's the configuration for a filter of 1 meter, 1.2. If you go in a 2 meter, then it's much more complex.
Yes. Yeah. And then, of course, as with all filtration, if whatever you're removing, whatever you're filtering out, you need to remove during backwash. Otherwise, you have a residual load which will build up over time, and your filtration will collapse. That speaks very nicely to this slide, which we've taken 2 filters, 640 ml diameter with a flow rate of 7.5 cubic meters per hour.
So Mike, this is exactly what we have seen before.
Yes,
Green is the blue filter.
Yep.
Red is the red filter.
Exactly.
640.
Yes, and so when you're utilizing the full surface area of your filter, 640, you've got a surface area of 0.3 square meters, and your flow velocity is 25 meters per hour, which is sort of our limit in aquariums that I normally recommend. Whereas with that red filter, as we were showing there, we've given it 400 millimeters, but I must admit I think it's less than 400, but we're being generous. With all the same flow rates, the surface area is 0.125 square meters, which means you're trying to filter at 60 meters per hour filtration velocity. That's just, it can't work, particularly in an aquarium and aquaculture with soft organics. Those just get sheared right through the bed, and your filtration does not perform.
In anything, I mean, AFM still will work in this filter. Will still work a lot better than sand. So that don't take me wrong, but you will not get what you could get out of a 600 millimeter filter. You pay 600, you get 400.
Yeah.
Yeah, from one side they look the same.
Yeah.
But they don't perform.
Yep.
Yeah. So that's a very important message, is that you're paying for the 640 mil, but you're actually only getting 400 mil.
Yeah, but you think you have a 600, so the system is not working as expected.
Yep. Okay, then I have seen this, and I really like that on shows where you had two levels of
double stack.
Yeah, double stack. That looks really sexy.
Yes, we have to start one above the other, because we try to minimize the dead areas that we have in the standard star configuration. They seem a good idea, but they are not. At the end, they are not a very good idea, because when you backwash, all the flow comes out from the top, not from the bottom star. So we have dirt generally accumulating in the bottom part. Yeah. So in the end, it's even worse, because we reduce the depth height.
Yeah, you reduce the depth height, you've increased the bottom section for building up of biofouling and dead water. And so your pizza slices are still there, even though you think you've got rid of them with the additional star below it.
So no double stack laterals. That's
no
the
double stack
message.
laterals, yeah.
Okay, but let's go for nozzle plate, because if you're nozzle plate, you're always super safe, aren't you?
You are not. You are not.
I mean, first of all, nozzle plate, we mentioned it before.
Yes.
It's always better than laterals. You're always on the safer side. And if you have nozzle plate, you can backwash it with air. That you cannot do, once again, with laterals. But give us a little bit of details.
Yeah, we can have this configuration that we see here when we don't have a space on the sides to put nozzles, or we can put nozzles shorter that we see later. But here we don't have a proper backwash on the side, so we will have the same effect as before.
So because they are laminating in, and then you can't place...
There are different reasons. One of them is that the technology that they use, they build the nozzle plate outside, and they fix it, they glue it, or they laminate it to the walls. So they need this space for gluing the...
So you lose there 10 centimeters.
You lose 10 centimeters, which in a filter of 600 you are dead.
Okay.
Or we don't have much space on the side, but we can still install a nozzle, but shorter than the previous ones. So all the air will go through this nozzle from the corner.
Okay, in water that would not be such a problem, that would be pretty okay.
Yeah.
But with the air wash, if one is shorter, then you destroy your air wash.
Yeah, this is very important when it comes to air backwashing, but with water not so much.
Good. I think that's a good one. Left we see cold blast property sign, out to the end really, and then on the right I don't know what the brand is, but very obviously you see here we have more than 10 centimeters we are missing.
Yep.
And then even in the middle you're missing again.
Yes, both filters has a diameter of 1.2. We want a velocity of 20 filtering, so we use a flow rate of 24. In case of on the right, we have a flow rate of 24, but the actual diameter is 1000. So the filtering surface is reduced from 1.2 to 0.8. So the velocity is 30. I mean, we are increasing 50% the velocity, and we have seen in the first slides how the performance comes down dramatically.
So that's again the same thing. You're paying for 1 meter 20.
Yep.
You only get 1 meter.
1 meter. Yep, same thing.
Good.
Yeah.
Or not good.
So here we can see a proper design of a nozzle plate. We have an even distribution of the nozzles. They come up to the wall. We need at least 60 nozzles per square meter, and we can see a proper backwash with air in this video.
Yep, there we go.
So that's typically cold blast, typically Gesura.
Yes,
you're testing everything.
Yes, we need to test everything.
Yeah, to make sure it works according to the design, right?
Yeah. Ah, very nice.
Great distribution.
Great.
Yeah, very good.
Okay, but you're not testing only nozzles, right? You're also testing laterals.
Yes, we test laterals. We said before that especially long laterals, they not perform as expected. We have different slots, and the longer the lateral, the more problems that we will have. So here we have a picture of a lateral.
Why is this?
This is that the water has space enough to go out from the last bit. The water has some speed, and it keeps the same speed, and this speed will be used to come out.
So it goes to the end, stops there, and this is why it's spraying just in the end.
And it's capable to go out only through these 5 holes which are in the end. If we modify the hydraulics and we close the holes and we make smaller holes, we can have an even distribution. But this is very difficult to do, and you don't normally do it as a general rule.
So, ladies and gentlemen, what you see here on top, that's what you usually get.
Yep.
If he treats it, he can cheat it and rework it that you have the one below, but usually it's not what you have. Learning, we want not to have long laterals, right? And you need the right speed. We don't go into details in this because he said you want to keep this as your secret.
Yeah.
But there is some logic behind. What do we see here?
Here we see what we want. We have a filter diameter of, let's say, 1.2, and we want an even distribution of the water coming out through all the lateral. And here is what we expect to have, and here is what we check and we test in CalPlus to know that we have a proper backwash.
So how you're doing this, you make your calculation,
Yeah.
and then after calculation you build a model, and then you check is your modelation, is your calculation working?
Exactly.
Good. Okay.
I think let's move on to the K2 of filtration.
Yeah, because
right?
I said horizontal filters is the most difficult to build. It's the
Yes.
Mount Everest, and you said no, it's the K2.
K2,
because
the most deadly mountain.
Yes, yes. Okay, tell us.
Good.
Well, we have we saw before that yes, the horizontal filters due to the geometry, they have the areas in many places, but also small changes in the design can make it better. So we have the classic configuration. We have example of the 10 square meter backwash 50. So we will have a flow of 500. This means that we will need to install a pipe of around 300 in the middle, from side to side, and this means that we will have a dead area of 300 in the middle.
So that's the standard design of most
Yes,
of the horizontal
this is a
filters.
classic
Big
design.
pipe below, big pipe above.
Yep.
Yes, we will have long laterals, but just take that into apart. We will have minimum dead area of 300 in the middle.
Yeah.
If we just change a bit the design and we have a pipe coming to the middle, to the center of the.
So also we come in with 300, but then we
Yes,
split it in
split
2
it.
times 200.
225.
Yeah.
Then we will have the area reduced.
So that's already a much better design.
Yeah.
This is a much better
Is that the
design.
design you're using?
No, it's not. This is not enough.
Still longer laterals, as you can see in the picture below. The laterals are very long.
So we can have a different design where we have split the flow into 16 pipes.
What do you mean we can't? This is how you're doing and Torre is doing it.
Yes, this is how we do it, and we don't do the previous two. We don't do that because they simply don't work.
Yeah.
So we do this design where we have smaller pipes and the area is reduced dramatically.
So you also come in with DN 300
Yes,
and they
yes.
get smaller and smaller to compensate for
Yeah.
the pressure drop. Then you split it in two, and from these two you go then for 2 lines with
Yes.
small laterals.
Yeah.
Yeah.
That's a lot of work. That's a lot of piping. That's a lot
Yes,
of.
it's a lot of work, but I mean design, but at the end we see that this is cheaper.
Yeah. So what you're saying, only with this you get the proper
The proper
performance.
performance, yeah. Both
Yes,
in
and
filtration and
we have
backwash.
the filtration survey that we think we have.
Yeah.
Okay.
Okay. So if we look at that, many manufacturers out there have different configurations of their laterals installed. So some try to get as low as possible to achieve as much media bed depth as possible, and that's a good thing. However, just purely because of the roundness of your horizontal filter, that really compromises the length of your lateral, and therefore you have very big dead areas both on the sides and in the middle, as we said earlier on, above the big pipe. So going from a 11.8 square meter filter, you can often end up with only 7 square meters. If you bring that lateral higher up, you have an even bigger dead area below the laterals. You have a shorter bed depth, so compromising filtration performance of the fines, as we showed you earlier on. But then your laterals are also a lot longer, which we've shown previously also don't work as well. The worst case scenario is if your laterals are very high up in the filter and very short. That really can't achieve much filtration performance after the first few backwashes, because this surface area is really only the active surface area that you'll be using.
This is roughly
in a short
half
space time.
of what you expect,
Exactly.
right?
Yeah, roughly half of what you think you're doing, and because of that, you are designing for a flow rate of 11.8 square meters, but you're only using 6 square meters. So your filtration velocities are ridiculously high.
Yeah, and that's also impacting our AFM.
Yep.
Also, that performs much better than SAP, but it will impact the AFM. You're not anymore on the 10 that we discussed or the 20.
Exactly.
You're double.
Yep. So this one is really talking about the long laterals again, and as Ursula said in the previous example, with your flow rate only coming out on the ends of the laterals, you tend to find situations like this where you have the dead flat surface in the middle of your filter and then the clean surface area on the two sides where the backwashing is actually taking place, and those are the two small surface areas that's happening. The rest is all dead area for parasite and pathogen breeding grounds and poor water quality.
Well, that's very similar to what you showed before with the short laterals.
Exactly.
So short or long laterals, in effect, doesn't play.
You're in a difficult scenario either way. So.
Okay, what's the solution?
So
I'm interested in solution. Huh?
We have this on top. We have this configuration, which is classic configuration.
That nearly everybody uses.
Yes, and we are covering most of the surface. But we will go in deeply and we put some numbers there. If we have 10 square meters, we want a backwash of 40, so a flow of 400 is required. If we have 110 laterals, the flow per lateral will be 3.6. If we have a configuration of internal diameter of the laterals of 16, we will have a velocity of 5, which is huge.
That's very big.
If we change to the design on the bottom, 220 laterals,
So
the flow,
your design?
our design,
Yeah.
the flow will be 1.8. So the velocity in the pipe of 16 will be 2.5. We can see in the bottom chart that for 1.8 we have a head loss around 600, 700, which is perfect for a backwash.
Yeah.
This is what we want.
600, 800
Yes.
Yeah.
If we-
millimeter.
Millimeter, yes.
Millimeters,
600 millimeters of head
Yeah,
loss.
yeah.
If we go to 5 meter per second that we have in the top, we will have a huge head loss. And not only that, we are in the vertical part of the curve.
Yeah.
So that this means that we will have a big head loss with small changes of
Yeah, but this is
and
an
that also will
exponential
need with
curve.
this high velocity, 5 meters per second. You shoot the water to the end,
Yeah.
and it will spray just at the end.
Yeah.
Yes.
Huh?
And because this is a exponential curve, the impact of your friction loss is dramatically
Yes.
larger the greater than 2.5 cubic meters per hour that you go.
But anyway, 5 meter per second is
It's just ridiculous. Yeah.
Okay,
Good.
Let's go on.
So we can summarize and we will put again some numbers to what we have explained. We have
Before you start, right, you see the concept Gulplas and Tara, because
Yeah.
you also make the developments for Tara.
Yeah.
And left is, we called it rest of the world.
Rest
I mean,
of the world.
what majority of all our other suppliers are doing, right?
Yeah.
Okay.
So we go for an example of a filter of 2.2 meters diameter and a length of 5.6 meters. So we will have a filtering surface of 11.8. If we want to backwash a 50, we have the backwash flow of 580, and the filtering velocity we want 20, so we will have 234. If we go to the design on the left, the rest of the world one, we will not have an area of 11.8 at level A. We will have 7.9. So the backwash velocity will be huge, 73, and
Which
the
is
filtering
good.
velocity
Yeah.
will be close to 30.
Which is
so
not
we will
good.
have 48% more than expected.
But previously you said high backwash velocity is good, so why would this one be bad, Hasura?
Yes, that's because this is not expansion, this is boiling.
Ah.
We will lose the media.
Yeah.
We think that the media velocity is 40 or 50, but it's 73.
Yeah.
So this is not what
And
we
it's
want.
centralized.
Yes. So you say all of the surface area that I'm showing here on the screen will be boiling up, and that's where we tend to see media loss.
If we go to our design, or the one on the right, we will have, instead of 11.8, we will have around 10.2. So we will have a backwash of 56 and a filtering velocity of 22.9, which is acceptable, and we have 14% more than expected.
Yeah. Well, life is full of compromises, especially horizontal filters, right? You have a little bit to compromise, but that's the very best you get out of this design. And yes, you will have no boiling. You also will have a little bit of loss of media in the beginning. That's the fines, that's the ancient share, as I call it.
Yep.
That's okay. But it should not be more than 5%.
It shouldn't be continuous. It shouldn't be ongoing.
No, it
at
should
every
stop.
backwash.
It should stop.
Yeah, so I like this slide, so I'm going to take this one very much because many of the manufacturers, or actually all of the manufacturers, give you the surface area of the B level, which is the greatest diameter of your filter, to tell you that this is the design surface area utilizing, but nobody out there uses the B to install your media, because then your media bed depth is so limited that quite often your filtration efficiency drops dramatically. So they generally fill up to a level of A. However, the level A, as you can see by a dome shape of a round filter, is that your surface area of A is less than B. Therefore, your filtration velocities end up being higher. So the one thing to be aware of is to make sure that when you are designing your flow rates for a particular filter, to use the right bed height that you're utilizing, and that surface area at that bed height. That can be calculated by the help of your manufacturer. In
Tara and Coplos, we give always these 3 levels in the future. You know, that you as the engineer, as a specifier, can go and see what you want to specify. Of course, we also give B to be comparable. What do you see outside?
You need to be comparable. No, great.
No, but it's an important one. Okay, one about the connection, and that's for horizontal filter, but also for vertical filter. And here you see an example from an Astral filter, very good filter, 2 meters in diameter. And these filters you can buy, you know, for 20 meters per hour filtration velocity, or how they say it, 20 cubic meter per square meter per hour. Or for 30, 40 and 50. And then you have a connection of only 110, or on the 50 you have 160. And ladies and gentlemen, please never ever use 110, 125 and 140. That's okay for filtering, but I guess from time to time you want to backwash this filter. It's not you put it in and you change the filters with the media. We want to regenerate, you want to backwash it, and then you need 50. And you absolutely cannot backwash a filter with 110 in a 2 meter diameter with 50 meters per hour. It's absolutely impossible. So please never ever use them. Go for these filters. These are good filters, but for the green with 160.
And filtering at a velocity of 20.
And filter at a velocity of 20. And for all the manufacturers out there, Astral and all the others, sell these filters with less than 160. That's not good. You know, that proves your competence, that you know filtration and backwash velocity are different. That was a little bit emotional, sorry.
Yes. But I can understand.
I really cannot understand it. It makes me angry.
No, I understand it for sure.
So we have concluded that we need a side glass. The side glass can be for different shapes. We have a very, very long one. We can have a circular one. We can have one on the top, or we can have a long one. But at the end, what we want is to check that we have a proper expansion and the media is
flat.
Flat.
This is why you need side glass, and you need good side glasses that you see through. If you don't see through, it's not a good side glass.
You will see out there some side glasses when they have not a very good design, so they have a lid outside, so there is media that is not expanding, so you cannot see what's going on inside.
Or you have some which are not really transparent.
It's not moving. And
let's make it short. You need a side glass that you can see through, and where you can control your filtration and your backwash.
For sure.
Okay, here we come to
the nitty-gritty.
Yes.
K2. How to solve K2 safely. So under Hosura's great engineering guidance, Tara has created a filter that I went to go and investigate to see how well it performed. We asked them to put in additional sight glasses so we can monitor the bed levels at all different points throughout the filter, and this is the video that we came up with. Sorry, it's not a professional video at this point in time. There are ones out there, but this is really to show the details of the backwash. So have a look at the video. Filtration performance, there you can see we were monitoring the different bed depths and the expansion capacities during the process. This was at filtration at 20 meters per hour, just to make sure that the bed was not moving in any way and wasn't kicking up on the sides.
So the flat bed was super
absolutely
flat.
flat bed. Then the first backwash was at 30 meters per hour, and you can see really great fluidization. We achieved the 20% bed expansion.
Equally through all over the surface,
throughout the
to
whole
the edge.
surface. Yeah, to the edge. And this view was actually
Well
from the side video, from the side window. So it showed that the overall bed expansion throughout the whole filter was great. Then at 40 meters per hour, you can see even better bed expansion and fluidization. We then bumped it up to 45 meters per hour. And this is a great video because it shows the expansion very clearly from the length of the filter, the window at the top end of the filter, and also that the whole surface is expanding very well and evenly, and the whole surface is also fluidizing. Which, I mean,
super clear.
To achieve this in, let's call it the K2, is unbelievable, and we are very proud of Asura for the design and engineering works that he's done, and also for Calplas, for Terra in the building.
Look at this, you know, how equal it is through all the filter bed.
Throughout the side.
Yeah, fantastic.
And then also to test, because sometimes we do heavy metal removals, and then we definitely want greater than 50 meters per hour. We also did a backwash at 53 meters per hour. And look at that great fluidization.
Perfect.
No loss of media, which meant that it wasn't just boiling in the center of the filter. And then during the slowdown phase, you can see where we were slowing down the velocities. You can see very evenly how the bed was dropping down into place, ending off with a perfectly level bed again throughout the whole filter.
Well, you have done it, K2. Congratulations.
Yeah, well
I
done.
think it's very, we can't really enough appreciate, you know, this design. It's really super difficult to do that you have equal backwash even at 30 meters per hour, and then that you can play between 30 to 50, 55 meters per hour.
What a lot of people don't understand is that actually backwashing at the lower flow rates to get your expansion is far more difficult than at the higher flow rates. So it shows a really, really good filter.
How are other filters performing? We do not know. We can't tell you. You also please do not send us how is this filter performing. We do not know. You can know because you ordered with a side glass, and then you make the same test, you know, and then you will see.
Yeah, and also just a quick review of the lateral design as per the drawings, or even looking into the filter will give you a gut feel. Is this going to, from what we've showed you, is this going to work well or not?
Okay, do we have one more slide? Or
just at the end, please follow us on all of the social media channels, LinkedIn, YouTube, and on our website we have a lot of download material.
On YouTube we have 3 different, one for pools, one for water treatment, and one for aquaculture. Some of them are similar. This video will be on all the 3 of these because it's such a very important one.
Yes.
For me, it was good fun. Thank you, guys.
Great. Thank you very much.
And thank you for your attendance, and hope to see you on the next webinar. Thank you.
Thank you.